Appreciate your presence and for your participation that you've been sharing these last weeks as we've had this class. Some of your suggestions and comments have been just excellent, and suggestions even on how to improve the class in the future. Just really appreciate those kinds of feedback, because I think I might know something and then I figure out I don't. It's nice to know that when you learn things about whatever subject you're teaching, or maybe the way you're doing it. So, we good, Matt? Everything's on. All right. So here we are, this passage up here to start off with in Jeremiah 51:5. He made the earth by his power. He established the world by his wisdom, and by his understanding he spread out the heavens. We all believe that. We all are convinced of that. And for very good reasons we're convinced of that. The scripture tells us that. And we have so many reasons to believe that our scriptures are from God. The evidences are overwhelming, even though we're not looking at that series of evidences during this class. But they prove without a doubt that God is our creator. And that what we're looking at is creation evidences. By the things that we see in the world around us, we can clearly be convinced that there's a creator. So, but it's just wonderful just to take a moment and just give thanks to God that he is so good and great in the things that he has made. He has been so generous, and it is so wonderful to be his child. And not only do we have all the blessings of his creation, we also have the blessings of his son and the sacrifice that he made. So those are things that we certainly want to be encouraged about every day. Okay, as we review where we were the last week or two, let's remember, it only takes something as simple as common sense to be able to figure out that God is the creator of all the things that we see around us and of you and me. Complex order and function and purpose don't happen by accident. Design is something that you can figure out whether something's been designed. That's the case with something like this watch. We spent some time looking at the fact that it doesn't take a genius, doesn't take a college grad, doesn't take any education to be able to see this mechanism and realize that it was designed by somebody. It functions for a particular purpose, and that's obvious to see. The same is equally true with this wonderfully designed creature and many other creatures, that it is not a product of accident and chance. It's a product of predetermined purpose and design. It has a complicated systems of function that fulfill a purpose of life that we all enjoy, right? Most of the time. Sometimes it's kind of rough. But anyway, we enjoy life for most of the time. It's so complicated, so magnificent. We've come up with this thing, which I didn't invent, actually. Michael Behe, we mentioned him, came up with this idea of irreducible complexity as a way to describe and a way to understand that evolution, this chance system, could not come up with any kind of functional life form. And the example is a mousetrap. You have all these parts. If you take just one away, it's no good. It doesn't function. It has no purpose. Evolution claims that things have to come about slowly, one piece at a time. And so if you had the hammer on this mousetrap, it wouldn't be any good, because you've got to wait another 100,000, 200, 500, 9 million years for the spring to come along and not only come along, but it has to be right where it needs to be. So things like this mousetrap, simple as it is, are irreducibly complex. This mousetrap was designed. It has a function. It has a purpose. As ugly as that purpose might be, it still has a purpose. So we can see that. The same is true with our seeing and our hearing. For the amazing blood clotting system that we have that functions so well, is so complicated, and then antibodies is just one part of our immune system, is a multi-step complicated process that comes up with a way to destroy bacteria that invade our body, or viruses, or other what's the general term? Anyway, bad guys. So anyway, that might invade our body. So they're tremendously complex. Last week we took a look, actually 2 weeks ago, we started with this guy, this Bombardier Beetle, who has boiling hot machine gun to defend itself. It's a complicated system. We looked at it. It's amazing. There's no way it could have come about by a system like evolution. This giraffe, tallest creature there is, has the largest heart. When it takes a drink, if it didn't have a complicated system of valves and the wonder net that stores some blood while it's bending over and taking a drink, it would kill itself just by taking a drink of water. But no, because it has this system that's been designed by God. The archer-fish, an impossibility for this fish to be able to hit its target unless it knows the math, complicated math of refraction that it needs to know to be able to hit this target that refraction puts in a different place than it looks. What do they call these things? Pardon? Sea anemones, that's right. It has this mechanism in its little feelers, this little dart with the poison sac and the spring, all these things, complicated mechanism, a trap door and a trigger, all these things couldn't just come about slowly. They are complicated complexes of machinery that these animals have. And then my favorite, the nudibranch, who swallows up this sea anemone and digests it all except for its little needles, and it transports those little darts up the tubes to the end of its feelers and uses them for weapons. Oh, I love that.
What was the name again?
A nudibranch. Don't ask me to spell it. Go back and look at the previous class if you want to know how to spell it. Nudibranch. So amazing things. Couldn't happen by accident or chance or a slow process of random mutation and natural selection. No way. It is obvious. We need to say, punchline here. We need to say, "O Lord, how many are your works? In wisdom have you made them all. The earth is full of your creatures." It's just obvious to look around that this is the case. So that's where we've been. Now we're coming up to a different section in our study, and that is the design in molecular biology. And you know the theory of evolution. Back in the mid-19th century, Darwin came up with this, and it became very popular among those who basically didn't really want to believe that things had to be created by God. It became popular very slowly until basically the middle of the 20th century. It became very popular. Today, it's like it's all that's taught in the schools, the universities, anywhere you go. If you want to have some kind of a position in some institution, you basically better be somebody who supports evolution, or you'll have sometimes trouble getting a job. And so it's so pervasive. Makes me wonder that even as obvious as our Creator is, that we have a Creator and all the things that we can see, that because things are even more entrenched in evolution today, that now God has allowed us to have a technology where we can see through microscopes some more amazing creatures that God has made at the microscopic level. Something Darwin could never do. Something that for ages up until the 20th century, man couldn't do. And now we can. And even more evidence that for creation. Miniature little creatures that function in our bodies and in every living creature. They're amazing. And you'll see it. I'm blown away. I always am by this kind of evidence, this microbiology that exists. So I don't know if that was God's plan, but certainly it's happened. We have this technology to be able to see life in a way we never could see it before. Life is already amazingly complex in a way that we can easily see with the naked eye. We've been talking about that for the last few weeks. All these different things like the ear and the eye, or these creatures like the beetle, the giraffe, the amoeba, or the anemone, all these things that we just talked about. Amazingly complex, just without any kind of magnification at all. We're just looking at what we see and how they function. We can be convinced, and for ages, people were convinced that there's a God because of this. But now we even have more evidence. It's amazingly complex at this level, but it's a ridiculously, amazingly complex in a way that we cannot see with the naked eye. And we're going to look at that. This, again, we're looking at God's creation in a way people couldn't do for ages because of science that God's allowed us to develop today. Okay, we're going to start looking at things at the microscopic level. There's our ear. We've already talked about him. We could be looking at this ear or an eye. We could be looking at a muscle. We could be looking at a crab, whatever. If we zoom in on any of those creatures or any part of those creatures, you begin to see things in a different way. Okay, well, now it's just a big ear, right? So what's big about that? Okay, we'll keep zooming in here, right? Zooming in on what we see. Any particular organ or creature, you get closer and closer. You start to see things that you can't see with the naked eye. The structure of tissue, just what it looks like. But even closer, you get down to this level where you start seeing things that are called cells. Everybody's heard of cells, and you know that we're made up of a lot of cells. 47 trillion, supposedly, up thereabouts. If you happen to be a bigger guy, maybe you got 50 trillion. If you're smaller, maybe you got 40 trillion. The trillions of cells, not just us, but every living thing, every life form are made of these cells. Okay, so that's not news, right? We all know that. But here's something we need to understand what Darwin believed about cells. Here's the microscope Darwin used. It's a little bit different than the mechanisms that we use today. Microscope of Darwin's day were very crude, low-powered apparatuses that could only magnify about 800 times. Now, that might seem like a lot, but it really isn't. The best image of a cell that could be seen looked like a very simple, uncomplicated blob of jelly. Basically, something like this. That's basically what they could see, and not even a good resolution. And so the conclusion was, okay, there's this basic form of life. It's the cell. It's just a blob of jelly. And somehow, some way, it comes together and forms different life forms, basic ones and complicated ones. And we figured it out. Well, they hadn't figured it out. They didn't know. They didn't realize that cells were all this was as complicated as life got. Until the invention of better microscopes and this guy, the electron microscope, which doesn't just magnify at 800 times, but it magnifies at 50 million times. That's a lot of magnification. In fact, it's called an electron microscope because it uses electrons as the imaging source rather than light waves, because light waves, they're too fat. They go like this. And you can only see something so small with a light microscope. With an electron microscope, electrons are much smaller, and you can see things at a better resolution, at a higher resolution, and a greater magnification. Okay, so great development in science opens up a whole world now of part of God's creation we could never see before. So the cell here now, just a few thousand degrees of magnification. We're not even getting to the millions, just a few thousand. Well, it's not just a blob of jelly. It's got all these parts in here that do something. It's got all these organelles that have purpose, that have complicated purposes. And now we're going to see what some of those things are. It has machinery, little machines that do things that allow life to exist and take care of certain processes. I'm kind of going on and on. Does anybody have a comment or a question? I haven't left anybody behind, have I? You see where I'm headed here. We're looking at God's creation in a way that looking down into this great magnification, and we can see things that aren't obvious to the naked eye. So this cell we're going to kind of represent with this graphic because it's much easier to see. It's a drawing made by somebody describing, but you can see it's got a lot of stuff going on in here. There's a lot of things that people didn't realize were happening on the basic level of life in all these cells that we have. And so we'll look at this cell kind of this way. We'll use this graphic for a bit and make some, and get a bit better understanding of what God has made on the molecular level, which is just as important as what God made on the everyday level. Because if you didn't have God making some of these things, all these things on the molecular level, you wouldn't have us today on the normal view level, right? These are the building blocks of life that God designed just as much as he designed the creatures we've been looking at these last few weeks. Bruce Alberts, in his article, "The Cell as a Collection of Protein Machines, Preparing the Next Generation of Molecular Biologists," in the publication Cell, February 8th, 1998, said this. He's an evolutionist, diehard, dyed in the wool. He says, "We have always," excuse me just a second, I just realized my screen that I'm reading from is smaller than it should be. Okay, there we go. Now I can read. "We have always underestimated cells. The entire cell can be viewed as a factory that contains an elaborate network of interlocking assembly lines, each of which is composed of a set of large protein machines." Actually small, but large in the context of atoms, at least. And he goes on. He says, "Why do we call the large protein assemblies that underlie cell function protein machines? Precisely because, like machines invented by humans to deal efficiently with the macroscopic world, our large world, these protein assemblies contain highly coordinated moving parts. You'll be able to see these are machines in the truest form of the word. They function just like the ones that human beings make." So, to emphasize how this basically changed the way the world looked at biological life, this particular person, in 2004, Antony Flew, perhaps the most renowned atheist philosopher of the age, the 20th century, renounced atheism and admitted to the world that an intelligent God must exist. He came out and said, look, for all his life, he was a huge proponent of evolution in his philosophy, argued for it continually. It was because of the recent discoveries in molecular biology. He could no longer accept that natural causes could be responsible for the complexity of the cell. Now, why the everyday level view of God's creation hadn't convinced him through his 80 years of life, I don't know. But when he started seeing over the previous 10 years or so of the things that we now can see in a microbiology, he was totally just thrown away. I'm going to read a few quotations from him. This first one, Richard N. Osling, from the article, "Lifelong Atheist Changes Mind About Divine Creator." This is from the Washington Times, December 10th, 2004. A big publication. Antony Flew said, "Biologist investigation of DNA has shown by the almost unbelievable complexity of the arrangements which are needed to produce life that intelligence must have been involved." Now I'm throwing this out because this guy is no small potato. This would be like if Billy Graham had come out 10 years before he died and said, "I don't think there's a God." Now, I believe some things Billy Graham believed, and I don't believe some other things that he believed. But the point is, as famous and as influential as he was, it would have been just like that. If he just would have stood up one day at one of his things and said, I was wrong. I don't believe there is a God. Now, if you can imagine that happening, that's exactly what happened to the evolutionary world when this guy stood up and said this. I don't think it could have evolved. It's too complicated. Another quotation from Antony Flew in the article, "Letter from Antony Flew on Darwinism and Theology," in the publication Philosophy Now. He says, "It has become inordinately difficult even to begin to think about constructing a naturalistic theory of the evolution of that first reproducing organism." Now, when it was a blob of jelly, he was okay with it. When they figured that's all it was. But when it turned out to be this, just as complicated on the microscopic level as it is, and even more so, according to him, than on the regular size level, he said there's no way. It couldn't happen. And I agree with him. Continuing with his quotations, this time from Stuart Wavell and Will Iredale in the article, "Sorry, says atheist in chief, I do believe in God after all," in the Sunday Times. No small publication, December 12, 2004. Flew said, "I have been persuaded that it is simply out of the question that the first living matter evolved out of dead matter and then developed into an extraordinarily complicated creature." Now, I know this is one guy, and even though his influence is great, he shouldn't really influence us. I'm just saying, look at what happened when the technology got a little bit better and people could see even more of God's wondrous world. One last quote from him. From Now magazine, August, September 2004, reported in, quote, "Famous atheist now believes in a God," carried by ABC News. Flew says, "It now seems to me that the findings of more than 50 years of DNA research have provided materials for a new and enormously powerful argument to design." Somebody must have designed it and made it. Now, as much as he was right, and his conclusion, he changed his mind. He never became a Christian. He never believed in the Bible. He believed in some powerful being who created things. He never accepted Christianity as being true. I don't know why, but he didn't. Not sure what he believed when he died about 6 years later after making these statements. But it just emphasizes the point of why we're taking a little bit of time to look at God's creation on this microscopic level. It's amazing. Yeah, Gary, wait for the microphone.
I'd like to suggest that this Anthony guy and all of his coworkers did believe in God, or they did believe in a God before he made this proclamation. They all say that evolution designs this. If you say that evolution designed the human body and designed all these animals and the earth, isn't that a God? It's a false God, but it's a God that you believe in designed you.
Yeah, it's a definition here, semantics. They think it's a natural process. You say you think he believed in God. I don't think
he believed in
he
a
didn't
God.
Say he believed in God. He believed in, the God of evolution, which is not a real God. They believe in the power of evolution, which is a simplistic thing. So, yeah, got your point. The point is that this time he came out and said, there's got to be a divine being responsible for this. Thanks, Gary. Appreciate that. So let's look at the cell's true complexity for a little bit as we go through and review a few things on the superficial level, really, and then we'll get a little deeper. Start off with worker proteins. Proteins are the basic worker machines of the cell. I don't show them in this view because they're too small to see at this particular resolution of the cell, but they're everywhere. We're doing jobs, many, many different jobs that the cell needs to survive. Okay, in order to do this, these worker proteins need power plants. Those are contained in the mitochondria. Actually, power-producing organelle that produces chemical power for the cell to function. Every living thing has trillions of these little organelles that produces power. We'll see how in just a bit. It's amazing how it's done. The cell has rows called actin fibers and microtubules. We'll see in a video or two some of these microtubules. They actually are roads that are constructed exactly when they're needed, and things run along them and drive along them. Just like in our big world. These cells have these kinds of roads. And then they have trucks called kinesin and dynein that run along these roads with doing various different jobs. Carrying proteins, pulling muscle tissue so a muscle can contract. We'll go into that in a bit. That travel on these roads. There are factories called ribosomes, those little purple dots you see. They're all over the cell in different areas, and they're responsible of making the proteins. And they do it in an amazing way. All this is so complicated and interrelated. It's just an astonishing function that they have. There are garbage depots. The lysosome collects worn out cells and disposes of them in a waste way that's a very sophisticated system. There's recycling. They're called chaperones. Some of the proteins that have been used for different reasons are recycled to be used again. Some have to go into the garbage, just like at home, right? No different, really. There's some things you can't reuse. The cell's that way. There's some things that can reuse. It's sophisticated enough, and the mechanisms are there that allow that to happen. There's a police station called the Golgi apparatus. This is the organelle responsible for what comes into the cell and what leaves the cell. You can't come in unless this guy says you can, and you can't leave unless he says you can. Sometimes it can be tricked. We know that. Certain bacteria can get through, certain viruses, we won't name it, can invade the cell and tricks this guy. And therefore, that's why there's an immune system that comes along and takes care of it. Or antibiotics. Or vaccines. We won't go down that road either. There's a control center. It's called the nucleus. It controls everything that goes on in the cell, makes all these decisions about what's going to happen and what's going to happen next. There's a data center that has all the information needed for the life to function and reproduce. And it is more complicated than we can even imagine. But we're starting to figure out more about it. Okay, so that's just a brief look at what the cell looks like. I mean, you get an idea. And this is just scratching the surface as far as some of the things that are in the cell. It's an amazingly complex thing. And I should say, let me back up before we go into there, is that everything in our body is made up of cells. We have skin cells, we have muscle cells, we have heart cells, we have hair cells, we have fingernail cells, we have brain cells, we have stomach cells, we have veins, we have everything. Blood cells, right? Everything is made up of these cells. These miniature factory machines that are very complex. Dr. Harold C. Urey, Nobel Prize holding chemist of the University of California at La Jolla, big guy in the business of microbiology, evolutionist, says, all of us who study the origin of life find that the more we look into it, the more we feel that it is too complex to have evolved anywhere. We believe as an article of faith that life evolved from dead matter on this planet. It is just that its complexity is so great, it is harder for us to imagine that it did. Well, then figure it out, Mr. Microbiologist. It is too complicated to come together by itself. And he admits that it looks like it can't possibly do it. Why do they believe it? Why do they accept it? He says it's an article of faith. They choose to believe that that's what's happened. They don't think that there's a God. Just one very influential person throughout the 20th century in microbiology. Okay, let's start looking at some of the cell's molecular machines. These things are pretty amazing. There are cellular power plants. We talked about those that are contained in what's called the mitochondria. Here's a microscopic machine that supplies most all of the energy needed for the many various mechanisms that operate in the cell. Everything that we work with today requires energy. That's the way it is in the cell. Everything needs energy to work. It doesn't work if there's no energy. You don't get function or motion or work out of nothing. Got to have these. And there are not thousands of them in your body. There are not millions, there are not billions, there are not trillions. There's hundreds of trillions of these little generators in your body. Makes you feel a little creepy, right? Shouldn't. This thing is called ATP Synthase. I don't see why they couldn't have just called it the cell generator, but they didn't. They called it ATP Synthase. Its one job is to produce this molecule. It's the energy molecule. And that's what it produces, is the energy molecule. Here's a very high magnification electron microscopic view of two of these guys. Usually they're in pairs. in the mitochondria. On the left is the one that's in the position of the graphical drawing there, and then there's one on the right, there's this other one. These are little machines that function continually, never stop, and produce the energy of the cell. Here's a short animation. This is from Stock Lab, the Victor Chang Cardiac Research Institute. And hopefully the audio will come across. And we'll look at, see how these things, this is an animation of what happens. And then we'll actually see a video of one actually working, but it's very hard to see. So here it is. No, it's not. Let's go back. Okay. It is a complex, you're exactly right. It takes the intelligence to make it and to work it. And the guy that made it was intelligent. Okay, is it gonna run?
Mitochondria, the powerhouses of the cells, turn over around 60 kilograms of ATP every day in an adult person. A long chain of biochemical processes convert the energy stored in food into a proton gradient across the inner mitochondrial membrane.
A little louder if you
These
can.
protons drive a rotation of the turbine within ATP synthase, resulting in the synthesis of ATP. Like all generators, ATP synthase consists of two separate motors coupled together. Within the membrane, we have the FO motor, named after the binding of antibiotic oligomycin, and at the top we have the F1 motor from factor 1. The FO motor is a proton-powered motor. It is thought that protons flow through a channel open to just the intermembrane space, where they bind to a ring of protein subunits, rotate 360 degrees, and exit through another channel exposed.
I'm going to pause it for a second. Instead of electrons, this uses protons to run this generator. And that's how it turns. And the protons turning this generator mechanically bind ATP with an energy molecule, and then they go off. You can kind of see them coming and going, and they go off and do whatever job's needed in the cell. Okay, let me continue on going, just so I explain it. So, and you can just see it rotate. If anybody's in mechanical at all here, if you worked on cars, you work with tools, you know what motors are like. You have a sewing machine, you got little motors in there. This is not this is a generator, which
only
is
to the matrix.
like a motor.
The net flow of protons driven by the proton motor force provides the energy for the generation of rotation. The torque generated in the FO motor is transferred to the F1 motor by a central stalk or shaft. The F1 motor is responsible for generating the ATP by addition of phosphate to ADP. The top of the central stalk acts similarly to a camshaft, so that as it rotates within the F1 motor, it causes conformational changes of the catalytic subunits.
Okay, just a little section of this video. This is a machine made out of proteins. It functions exactly like a generator that we have today, except like I said, instead of using electrons to make the generator or producing electrons, it produces a different kind of protein molecule. It's got a camshaft, it's got a rotor, and we'll see, it's got a stator, it's got it's a machine, and it's amazing. Do I have to see a hand, Mike?
That other view, was that the DNA track that was going on there, or?
Mitochondria, the powerhouses of the cells.
I can't really go through this yeah. What were you asking?
Is that DNA that it's tracked?
No, that's just that's the cell membrane in the mitochondria. Those little capsules, there's thousands of these in that little mitochondrial capsule inside the cell, and they constantly go generating the energy the cell needs. And these ATP molecules go off and do whatever's needed. Okay. Again, these are things we probably want to go through once, and then if you want to, you can look on the website, or if you want to look at it again. I think it's just absolutely amazing. It's no different than a generator that's in our car as far as its function and the kind of components it has. They're rougher looking, and the reason these are so rough looking is you can't get any smaller than this. The reason your generator in your car looks smooth and metallic is because we're not dealing with protons there. You're just dealing with steel and other things. You can't get any smaller than what you're looking at here. So here's a short video just showing it functioning. This is at, I forget, 45 million magnification of this ATP molecule from the top doing its job. And like I say, you've got hundreds of trillions of these things, these little generators working in your body. Every part of this guy, oops, is so complex. Again, it's the same argument. It's irreducibly complex. What good is that stator arm and assembly if it evolved somehow on the protein level, if it didn't have a rotor or a stator or a camshaft that went around and mechanically moved those parts out so it's too complicated. This is obviously designed. Just like that Bombardier Beetle with its particular complicated process of producing 4 different complicated or 2 particular high quantity, if you remember, if you saw it, if you didn't see it, go back and look. Complicated process for this beetle to do what it does. That's at the microscopic level, just as much, if not more, than at this level. Irreducibly complex. Now, just to give you an idea of scale here, how small these things are. I'm not sure if I'm going to be successful at doing this, but Mike Putterbaugh, how tall are you? 6 foot. Okay, here's one of these. How big or small is that? Well, it's 20 nanometers tall. What does that tell you? Not a whole lot, because we don't usually work in nanometers. Okay. Carpenters work in 1/16 of an inches. Electricians, I think you get down to, what, 1/4 of an inch? I don't know what it was. It's pretty small. Okay, well, if you, looking at the amazing how small it is. See, not only these things are so sophisticated, they're so amazingly tiny, tiny, tiny. Mike, if you could grow from your 6 feet to a height of the Earth across, 8,000 miles approximately is how far across the Earth is. And then you threw a baseball at your feet. That's your 8,000 miles tall now. That's about the proportion of an ATP molecule to what your body would be. Of course, you're not 8,000 miles tall, but if you were, that's about how big it is. Shrink it all down to regular size, and it is so small. Again, hundreds of trillions of these little things that don't occupy very much space at all in our bodies, working all the time. It's amazing. It's just like evolution can't begin to explain how this could be. Little molecular generators or energy generators that are in the cell. Okay, we got about 10 minutes left. Let's look at a few more and see how far we get. Bacteria flagellum. I know, funny names. Bacteria, you know what that is, right? I think I know what that is. Okay. Well, the bacteria flagellum, just put propellers or motors in place of flagellum. Bacteria flagellum is a molecular propeller and motor that many bacteria use to drive them around wherever they want to go. Okay, I'm sorry. You have a comment that I missed?
I just want to share how excited I am about all the stuff we're learning, because last week the kids were excited. They were talking about it, and then I said, well, I'm going to go over Genesis 1 and 2, mm-hmm. And it took on so much more meaning about how powerful, I'm even shaken talking about how powerful our God is. Amen. That I want to share his word with the world, because when I read it, I was like, in my mind, I was saying, what can I learn from Genesis 1 and 2 again? Because I've read it so many times. But I did. Yeah. And it just came out how powerful our God is, because he made the tree already with the seed. It wasn't like he doesn't know what he's doing.
That's right.
He made the human completely grown, ready to bear children. The cow, we can answer the question, did the egg or the chicken come first? We know the chicken came first, but it was able to bear. And
good problem,
it's just amazing. And we just need to share that more with the world, how powerful.
Yeah.
You know,
there's
it's
so
undeniable.
much to share. There's so much to share. The gospel primarily, God's word, but also all these things around us that we look at all the time. Scream out, shout out, there is a God. Thank you. Mike, do we need to go back?
What it comes down to, ultimately, is that the world doesn't wish to embrace the thought that a all-knowing, all-powerful God created all things, because that would have implications on our lives. That would mean that we are, going to be accountable for the lives we live. And individuals like Antony Flew, we talked about earlier, lived his whole life under the shadow of an atheistic viewpoint. And I don't know his personal life, but the people he influenced, their personal lives, often take such a different course, because they don't think they're ever going to have to give account of themselves to God. And certainly that, I think, the conclusion they want to reach drives the belief system that they want to embrace. And so much of this evidence is never even considered.
I think that's a huge motivation for why many people will not accept that there's a creator. It's not because of the evidence. It's not that at all. The evidence is there in so amazing amounts. It's because of, I don't want to be accountable. I don't want to have to live in a way that I choose I'd rather not live. And you can't judge. I'm not going to judge you. I'm just saying that I can see it happening. People have said it. We read a number of quotations of the reason that there is this theory for some of us is because we don't want to live. We want to have the women we want to have, and we want to do what we want to do. If you remember that quote way back near the beginning. Yeah, exactly. Okay, next machine. Bacteria flagellum. Are bacteria good or bad? Okay. Some are beneficial. Many are beneficial. You couldn't digest anything if you didn't have bacteria down there doing its job. Are there harmful bacteria? Yes. That's the ones we hear about most of the time, because we hear about bacterial infections. Bacteria get a totally lame reputation because of that. Okay, and it's there, and I'll say my understanding very clearly is the reason there are harmful bacteria is because of the fall. Same reason there's death. Wasn't supposed to be in the beginning because of the choices Adam and Eve made. There was the fall, and the earth was cursed. Some bacteria went the wrong way and became our enemies. Okay, but be that as it is, here's a bacteria. It has this molecular machine called a bacteria flagellum. This microscopic machine consists of a rotary motor and a whip-like propeller that rotates at speeds up to 20,000 RPM. Here's a graphic of it. You say, well, somebody just came up with that. Here's an electron microscopic picture of it. This is an actual machine on a molecular level that drives bacteria around. It's amazingly complex. Like all the types of electric motors that we know, today it has things like, can you see my, no, you can't. Can you see, where is that? Laser, that's right, out the backside. All right. It's got a stator, it's got bushings, it's got a rotor, it's got a U-joint, it's got what's called a filament, and we'll look at this in more detail, but it's a functioning a motor that has a propeller system. It doesn't look like the propellers we're used to, but it's very efficient. Okay. Though the components of this motor are made up of proteins instead of metal rings, brass bushings, and ball bearings, their design and function are identical to man-made rotary motors. They do the same job. They're made very similarly. Here's a video by the Protonic Micro Machine Project showing, to begin with, electron microscope view of bacteria swimming around with these flagellum. And then we're going to zoom in. Do I have time to show this? I don't know if I have time to show this. I got 3 minutes. No, ain't gonna happen. Okay. Sorry, I should have watched more closely. Gives you something to look forward to next week. We have a number of more molecular machines to look at. I'm hoping you're beginning to see that life is sophisticated. It's complex at a level maybe you never knew before. I certainly didn't know before a number of years ago that there were these mini micro machines running around that have jobs to do. And we look at different questions like, how do they know what to do and when to do it? That's a whole different level of complexity that we don't even have probably time to, we're going to go into looking at DNA a little bit, but there's so much information in the cell that cellular biologists will tell you we don't even know where some of this comes from. We know that DNA has the programming it needs to reproduce things, but we don't know really why certain things happen when they do. We don't know why, how these little electric ATPs go over to certain machines when they need to. Mystery. They just don't know how a lot of this happens. We're looking at what they do know, but it's enough to see that there is amazing design at a level that maybe we just haven't thought about before, and it should be convincing for everyone to see that this is something that couldn't happen by chance. And we'll look at that more. This is evidence of God's design and creation. Praise his name. Amen. Thank you for your attention. We'll get on to some more of these amazing machines next week, Lord willing.